Okay, welcome to a CO2 compressor webinar. So we're going to talk today a little bit about what you need to know. And it's important to get a good idea on CO2 before you work for it, work with it, because I have a lot of buddies who work in supermarket and refrigeration, commercial refrigeration, and they're on call. All of a sudden they get to a store and it's their first CO2 store and they haven't had any training. So it's good to brush up on CO2, at least get the basics understanding. Once again, CO2 is just another refrigerant. You just need to be aware of some of the things. A little bit about me for those who don't know me. My name is Trevor Matthews. I'm a refrigeration, first generation refrigeration mechanic. I've started in HVAC, took a HVAC program, then I got into refrigeration, got into supermarket commercial refrigeration, and then gas fitting. Then I started with a company I worked previously with Copeland. So I worked there as a national trainer, and I've done a ton of CO2 training. For the last 7 years, I've been learning about CO2 as a refrigerant. The last 4 years, I was a national trainer for Copeland and doing the CO2 training. So I've actually trained hundreds and hundreds of technicians in person on CO2. So showing them how to start up a system, how to charge a system, actually how to troubleshoot on a CO2 system, which was really fun. This year, I started a company called Refrigeration Mentor. Went out on my own because I really seen a need of helping technicians and contractors out in the field to get better at what they do. And I'm really excited about this this new venture that I'm on because I'm getting a ton of feedback. Work is coming in very fast, and if anyone here has been a trainer in the field and looking potentially to start training in refrigeration, let me know. We'll have a conversation. So this is a little bit about my history. Lots in, like I said, in CO2. Today's agenda, what we're going to talk about, we're going to introduce CO2. We're just going to talk about some key features of it. And then we're going to get into reviewing some Copeland and Bitzer CO2 compressors. I did have Durain on there, but I don't know if we'll have enough time. If we do, we'll get into a little bit of those. Have many of you worked on CO2 just by a show of hands or shoot in the chat? I see a question here already. Toyin, what's the difference between CO2 booster and CO2 with ejectors? So CO2 booster is just a standard system. You wouldn't have ejectors, parallel compression. We don't dive into that today, but it is a difference. So the CO2 booster is just a name, so it means transcritical system. But if you have a basic system, you wouldn't have ejectors, or you wouldn't have parallel compression or adiabatic cooling. Okay, great, Paul. Yes, so Pat has, Jared have, Dean, a little bit about this. Thanks for the question. So then we're going to review some of the application designs. And what I mean by that is I'm going to show you where to find the information quickly, because I think that's the most important thing. My years working at a manufacturer, I really hone my skills and find the answer quickly. As technicians in the field, that's what you want to do. You definitely want to find the answer as quick as possible. And when you can do that, it helps you build confidence in what you're doing and find the answer out quicker so you can resolve that problem for your customers. Okay. So CO2, some key facts. So 1 bar equals 14.5 psi. With CO2, you're going to start seeing here in North America, we talk in refrigeration, because in Canada it's a little bit different. But when we're talking about refrigeration, we're talking about Fahrenheit and PSI. In Europe, in Australia, I worked out in Australia, you're talking bar and Celsius. So you need to understand conversions. Doesn't matter where you're at in the world, because now you're getting equipment from everywhere. Some may be in bar, some may be in PSI. You just really want to understand that. I highly recommend downloading an app on your phone that is a converter. So temperature converter, pressure converter. I use it all the time. I'm getting a little bit better, but you need to understand conversions. Next thing, temperature difference. You're going to see a lot, especially in CO2. We talk in for superheat, for example, this is our subcooling we'll talk about here in North America. We'll say 10 degrees superheat. And that would actually mean 6K. So that's the temperature difference when you're talking Kelvin. We use Fahrenheit. Just once again, understanding these conversions because you're going to see them in CO2. Okay. Critical point. What's the critical point? Does anyone know? You can unmute yourself and tell me what the critical point is, or you can put it in the chat.
Isn't it just above 1,000?
Yeah, close. Yeah, there is a critical temperature and a critical pressure. Does anyone know where it's on this graph? Thank you, Jared.
At the top of the curve, isn't it the point where it doesn't change state anymore?
Exactly. Right here. This is the critical point. So on this right hand, this is from Danfoss Cool Selector 2. If you don't have this software, I highly recommend downloading it. It takes a little bit to learn, but there's so much great information in there on Danfoss products. But right at the top of the curve there, that's the critical point. Every refrigerant has a critical point. Okay. We just don't see it with HFCs or HFOs or CFCs back in the day when there was a, because we never got to that critical point, critical temperature or critical pressure, because it was so high. But now with CO2, it has a really low critical point. And you'll see it at 87.8 Fahrenheit or 31 degrees Celsius. So when you're above that, you're in what we call our transcritical or supercritical zone. And that would be, if you can see my cursor right here, right up here. So when you're up here, that means you're in transcritical mode or you're in that supercritical fluid zone. So it's not really a liquid, it's not a vapor, it's like a fluid. And I've seen it many, many times. One of the trainers I used to work at, you could put it into transcritical and you could see that phase. You can change it from liquid to vapor to that transcritical. So it's important to know that because most ambients, most climates will get above that. Because CO2 was mainly in the regions where it's cooler out, like Canada was a great spot, anywhere it's north of the equator. Like when you start to get closer to the equator, it gets a lot warmer. So it was a lot harder to have CO2 because CO2 is not new. CO2 has been out for over 100 years in refrigeration. But newer synthetic refrigerants here were easy to use, lower pressure, and we went through a cycle of having synthetic refrigerants. Now we're back in natural refrigerants. You're going to start seeing them heavy. Regulations is pushing CO2 or natural refrigerants. You're going to see more CO2. You're going to see more propane. You're going to see low GWP refrigerants, and which I mean by that is global warming potential refrigerants, like A2Ls, which are mildly flammable refrigerants. If you have not seen them already, you're going to start. But there's going to be a massive influx of CO2 equipment in the next 10 years. There's already a lot, especially here in North America and around the world. You're going to see a lot more. Japan has they have tens of thousands of CO2 units, like heat pumps, for example. Water heaters, another example. But there's over 30,000, I believe probably over 30,000 supermarkets. I'm with a group called Atmosphere, or they used to be called Sheco. Great group. If you guys want to join and learn more about natural refrigerants, they got a great Slack group. I can send that to you. But it's good to understand where it's going. And I'll tell you right now, here in North America, there's going to be, at some point, it's going to be all supermarkets going to be natural refrigerant. In Quebec, one province here in Canada, it's anything over 50 kilowatts, which is 67 horsepower, which is not a big rack, needs to be below 150 GWP, and that's pretty much CO2. California's got a lot of regulations. They got an alliance there, so you need to understand this. A little bit off topic there. So transcritical, it's anywhere's above there, of that point. We talked about that critical point. So anything above here, when we get up here, is the transcritical zone. Subcritical. That's where all our refrigeration equipment works now. So if you work on 404, 448, 449, 134A, we're always running in the subcritical zone because that critical point's so high. So it's really important when you talk about a booster system, you're going to have the medium temp, which will go into transcritical, and then you have your low temp, which is going to stay in subcritical. So that's your freezers. Any questions so far? Okay, triple point. The triple point is something very important to know, because when you're charging any CO2 system, you need to be above the triple point. If you try to charge a system below the triple point, what could happen? Anyone?
Dry ice.
Dry ice, exactly. And I've tried, to be honest with you, on demos and trainers. I actually pulled things into a vacuum and blasted liquid in there, but I don't think I did it right. Maybe because it was a 1/4 inch lines and it was flashing it, but I've tried. I pulled things in a vacuum and blast liquid in there. I couldn't cause dry ice, but I've seen time when I was pumping down a circuit and I want to make dry ice, and I pulled off you got to be safe with CO2, wear gloves, glasses, be very safe. But I pulled it off while I knew there was still liquid to make dry ice. But I had to try to do that. I know it does happen, but I've talked with hundreds of contractors who've been working on system, and they haven't come across making dry ice, even though I've seen it and heard about it.
Taking the liquid dryer shell apart, you can usually make it pretty quick. My
Yes.
experience.
Yep, exactly. And I've seen it done there many times when you're changing the filters. So you need to be aware of that, because when you are pumping down a system like Jared's saying and you're changing that core, you're making that really cold. And if you get dry ice in there, it sublimates after it. So it's going to take a while. The best thing is to probably close it up, raise the pressure, turn the liquid and get rid of it. But you're going to want to clean that out. You don't want, and then pull a good vacuum after that. But you don't want dry ice in your system, because it'll start plugging up sections of your system, and you can run into major issues, especially if you cause some dry ice and then all of a sudden you think that coils evacuated, and then you can run into non-condensables in your system. So here's the triple point region. It's good to understand where that's at. You just don't want to get into a dry ice situation. And if you ever seen dry ice before, it's just a little block, really cold, minus 109 Fahrenheit, I believe. And when you're getting that in the system, you're going to run into a world of hurt. Trap liquid. This is really bad. You do not want to do this. At 68 degrees or 20 degrees Celsius, you're looking at like an 868 PSI pressure. So in cylinder, we'll say. If you all of a sudden bring that temperature up by 1 degree Celsius, 1.8 Fahrenheit, it expands by 10 times. So you're going to see a massive amount of pressure increase. That's why you never want to trap CO2. You'll see along a lot of ball valves and stuff, there'll be check valves around it to make sure you don't trap CO2, because it is dangerous when you do that. Any questions so far? No? Okay. So minimum superheats. Now, this is something that's super important. When I was working at Copeland, I used to do a lot of field support and take a lot of calls. And there was I got a call after there was, I believe, 14 compressor replacements. They just kept sending them some compressors. This was back in 2015, I think. 14 compressor replacements on a rack because of superheat. Does anyone know what the minimum superheat for medium temp would be?
35 degrees.
Yeah, 35, 36 degrees or 20K. You need to stay above that, because CO2 doesn't carry with the POE oil the same way as like HFC. Very highly soluble. So what will happen when you start getting below that? Sorry, medium temp we were talking about, we said 36. No, it's not 36 for medium temp. That is low temp. Medium temp is 18, 10K. Low temp's 36. So that was my mistake. But CO2 is very highly soluble in the oil. So what will happen is that if it has flinger feed, as it's going through the cranking or it's feeding the bearings, it'll start to wash them out. It'll start to dilute the oil when you start getting below that and start to cause issues. And this is where I've seen many compressors fail, because a lot of people do not check compressor superheat. You should be really checking the compressor superheat on any system. Or some people call it total superheat, some people call it system superheat. So you have your evaporator superheat, and then you have your compressor superheat. And it's so important to check that on any system at all. Always check that, because if you're running below that with CO2 systems, you're going to start to wear those bearings out, and you're going to cause a failure. And I see most of the compressors failures that I've seen anyway with CO2 were due to liquid washing the bearings and washing the oil out. Anyone have experience with that in the field? Have replaced any compressors and because of superheat that failed? Okay. So let's talk about some Bitzer transcritical compressors. There's lots of great information out there, and you'll see up in the top corner I got an image from Bitzer software. If you don't have the Bitzer software or B-Spot on your phone, you need to download if you work on Bitzer compressors. The information I'm going to talk about right now is out of the KB138. I'm going to show you how to maneuver that. I'm going to go through this section. I think it's highly important for you to understand where to find the information from the manufacturer. And there's a lot of CO2 compressor manufacturers, and I'm talking a lot. But the main ones that I've seen here in Canada anyway, it's for commercial would be Bitzer, Copeland, there's the odd Doreen, and I don't see much more on that. If you know, I know Jarrett works in some stores and stuff. If you've seen any different, let me know. Throw in the chat the other CO2 compressors you work on, because I know Panasonic makes some, you know, Bach makes some. There's a ton of CO2 compressor manufacturers out there, but here in Canada, North America, we see mostly Bitzer and Copeland. Okay, so this information is out of the KB130. So there's two different types of oils they recommend. So the BSG 68 for cascade systems. And what a cascade system is, you'll have one refrigerant on top, we'll say 448 on the top, or ammonia or whatever it's on the top, propane. And then on the subcritical side would be your CO2. The other one's a booster system where you're doing CO2 on the transcritical side, the medium temp, and you have the low temp CO2. And you're actually pumping, and that low temp compressor is actually discharging into the suction of the medium temp. Okay, depending on how they pipe, but that's really how it works. That's why it's called a booster system. The low temp compressor is pumping into the medium temp system. Okay, CO2 grade, this is very important. So Bitzer and Copeland and other manufacturers have different grades. They talk about different grades. So Bitzer says they want an N4.5 or less than 5 parts per million of water. So this is above Coleman grade 4. It's the next level up. Coleman grade, which Copeland recommends, is grade 4. They call it Coleman grade, and that's less than 10 parts per million. They say if you cannot get Coleman grade, because it's hard. It depends on where you're at in the world. You might not. It's not easy to get CO2 refrigerant right now everywhere. We have provinces that are on islands, and they can run out of CO2. It can happen, and maybe some of you may have struggled with this. So I've seen store owners actually have a whole charge sitting at their store to make sure they don't lose the charge. If they do, they have a backup, because it's hard to get CO2 sometimes. A lot of the time, if you read in the manual, the KB130 here, they'll say they want you to charge through a filter if you can't have Coleman grade. There's other ones that say you can use lower grades depending on the OEM manufacturer. I always say the more dry refrigerant, the better, because moisture is really, really bad in the system, because it causes copper plating, causes acid, causes a lot of different things. Vacuums. You want to get that system down to 500. Bitzer likes want to get down to 500 microns, 0.67 millibar. And I want to get below that. I've been doing a lot of research, actually, to be honest with you. And I'm seeing some people saying 1.5 millibar, which is actually like is it 750 microns per millibar. So it's like 1,000. So I need to look into that a little bit more. Why they're saying 1.5. I don't know if anyone ever have heard that or read that or seen that, but it's a lot higher than the 500 microns that I recommend, and it should even be lower than that. I worked with a manufacturer here called Septac. They're out of Quebec, and he's 250 microns. That's what he wants. And I've been on many advancer calls, and they're saying like oil changes need to be done a lot more. They want oil changes done in their racks because they're seeing there's a lot of moisture in the system, and that causes major issues, especially with CO2, because it can freeze up valves very easily and plug things up. So you need to understand what the manufacturers are recommended. And I know I've been on many job sites. I've worked a lot, and there's tight timelines. Jared, I'm sure you've been involved in doing any construction. You know, you get a job, you got to do a whole lineup in a night, and then have it up and running. You know, a lot of really should be pulling a vacuum for hours on end, or whole pressure testing for 8 hours. That's, you know, there's certain regulations. Does that happen in when you're doing renos? It doesn't happen, but you need to try to do your best to follow proper procedures, because if not, you get a store up and running and stuff, issues start happening down the road because of that installation. That's mostly what happens is from day one installation. That's when problems arise. So if you don't pull down to below 500 microns or 0.67 millibar, what's going to happen is that you're going to get moisture into that POE oil, or depending on the oil, this is the BSG, which is a POE type oil, I believe, maybe a PVE, but I'll have to double check that. What's going to happen if that starts to develop acid in that oil over time, like that compressor may fail, or those compressors may fail 1, 2, or 3 years down the road. When I worked with the compressor manufacturer, this is what I was seeing. Because of that day one installation, they didn't pull the proper evacuation. Compressors fail down the road. So it doesn't happen next week or in 2 months or 6 months. It happens 2 or 3 years, because these compressors, Bitzer compressors, Copeland compressors, Rain compressors, they all should be lasting 10, 15, 20 years if they're serviced properly, installed properly, maintenance properly. Once again, any questions, throw it in the chat. That's what else. So what else did I see here? So inverter duty. So you have to take a quick, deeper look at this. They can go from 25 hertz to 87 hertz, but it all depends on the compressor. Some will not go down to 25, some will not go up to 87. So you really need to get into 130.8 and look at that specific Bitzer model number you have when you're setting up a VFD. If you do not know how to set up a variable speed or inverter on a compressor, you need to start learning this stuff, because it's happening. It's out there already. You don't want to be the technician just bypassing, going in there on a service call, just bypassing, and it just stays, because that really throws everything off. And I'm seeing this on dozens and dozens of stores. You know, they do a retrofit, they put a variable speed drive on a compressor, and then 6 months later it's just bypassed because the technicians don't know how to work on it. If whatever you're working on, if it's CO2, if it's an inverter, VFD, you got to learn that stuff. I know it's outside the comfort zone. You don't have time. You got to do it in the evening. You got to do it just like this. Understand how you work, the equipment you're working on. It's going to make you such a better technician. You're going to have more confidence. You're going to be more confident in your work. But make sure you check the specific compressor you're working on, especially for Bitzer, because they have different inverter duty ranges. Charging procedures. Bitzer wants you to turn on that oil heater first. Copeland does as well. Most all of manufacturers will say this. They want you to heat up that oil, so there's no migration. What migration is that refrigerant is going to travel to the coldest part of the system. If that compressor is the coldest part, it's going to travel there. Refrigerant's also chemically attracted to oil, so it's always going to want to go to the compressor. So they want you to turn on the oil. Do not start charge until the minimum oil temp is equal ambient plus 20K or 36 Fahrenheit. So if the ambient, for example, is 20 Celsius, they're looking at 40 Celsius oil temp, or 36 on top there. So if it's 60 out, be 96 oil temp. This is, I haven't seen this. This is not in the Copeland guides. I haven't seen this, but this is a good way to check. Purge refrigerant lines through high and low side. So actually no different than your standard refrigerant, getting that CO2 vapor and purging those lines so you're not getting anything into the compressor. Closed suction and discharge lines to the system. So I've seen this here when you're evacuating, when you're pressure testing the system, they want you to close off that compressor, which totally makes sense. If you're pressure testing that system and you leave that compressor open, this should be a standard anyway, but you should shut those suction and discharge valves. So you're not getting anything inside that compressor, because you could get moisture, you could get air inside there. You don't want that. And slowly continue. So what you need to do is you need to charge the system with vapor. So when you evacuate it, you get it down and you start to charge, you need to charge with vapor first, because we talked about it earlier, dry ice. Dry ice is anything below that triple point, which is 71 PSIA. You want to make sure you need enough vapor. So I see Bitzer says 145 PSI or 10 bar. Copeland says a similar thing. When I look at manufacturers, some manufacturers, OEMs will say 100 PSI or 120 PSI, which is just under like 8 bar, 10, 9 bar. But the big thing is I've started CO2 units at 100 PSI in it, vapor. But you just need to make sure that whole system has vapor in it, because you don't want to get one section all of a sudden get plugged with dry ice. Okay, they say in their manual that their cycling rate 6 starts per hour. So this is something you need to watch for. I've walked into many rack rooms, parallel rack rooms before, and I hear compressors banging on, banging off, banging on, banging off. They say 6 starts per hour in their manual. So start, stop, minimum start time is 10 minutes. So like runs for 5 minutes, off for 5 minutes, that's 10 minutes, or whatever sequence is that. But they always want the oil heater as well on when the compressor's off. And this is just a standard in our industry, but just make sure you check that crankcase heater. I've seen it many, many times going in, or 2 or 3 of them on a rack are not running. So you always want to check that oil heater, very important. Minimum superheat on this transcritical compressor is 10K or 18F. So they want that because that solubility that I talked about before. You can start getting below that. That CO2 is enriched. It's going to be enriched oil, and it's going to dilute the oil and cause bearing wear. A lot of them that I see, though, they're going to have a special design. They could have a heat exchanger. So what happens is going to be taking discharge gas into the suction, and it's going to meter that in there by an electronic valve to make sure you always stay above that. And you'll see this definitely in the low temp side. Different manufacturers have different designs. I know in Advancer, they'll have a loop for the low temp going in through the flash tank receiver to make sure they're always staying above 20K or 36. Oil temperature, I want it 30C or 86 degrees Fahrenheit. Absolute minimum 20C or 68 degrees Fahrenheit. When you start to get your oil that low, you're starting to get it to 20, 10. There's something going on. There's dilution going to be happening because your oil's so cold. Why is your oil so cold? If your oil is that cold, that means that return gas, that suction gas coming back is super cold. So you need to understand, why is that happening? Why is my oil so cold? It's pretty cool that they put this in here because I don't see it in a lot of manufacturers' manuals. Minimum discharge temperature. So it's your condensing temperature plus 40K. So that's what the minimum discharge temperature they say. Once again, I've only seen this in the Bitzer manuals, but I'm sure it's in other manuals as well. Maximum discharge temperature, 140C, 284. So this is a little bit different than Copeland, which we'll go through, but it's something you need to be aware of. When you start getting above 300 with POE oil, it starts to lose its lubrication properties. When you get up to 350, I think 330, 350, I can't remember right now, it starts to break down. And I've seen this before. When you start running that hut as well, if you start running that hut in your system, your oil separators, you got to remember this, your oil separators only pull oil out of the refrigerant at certain temperatures. When it's running too hot, that the viscosity of oil is not right, and it's not even going to be pulling oil. So you're going to start having oil issues on the system. So just be aware on the temperature of running. Verify that oil separator, what the temperature should be, max it should be running at. If it's Temperite, if it's a Westermeyer, whoever it is, and Henry, I think as well. You want to check those out and make sure, because when you're running hot and you're starting getting a lot of oil issues, maybe that's one of the reasons you're running too hot. Okay, so this is the Bitzer subcritical compressor. I didn't want to go through it step by step. I just wanted to do that one. A little bit different. Their max on the subcritical 75 hertz, not 87. All the rest of the stuff, they really talk about being the same, but the minimum superheat for the subcritical, this is the low temp, is 20K, 36 degrees Fahrenheit. You need to keep that. And you need to have monitors. One thing that I love about CO2 systems and working on parallel racks compared to the old school ones that were all mechanical, I can see everything. So if it's on a microthermal, if it's on an E2, I haven't did much work on Danfoss, or if it's on a Danfoss, you can see everything that's going on because there's pressure and temperature transducers everywhere. So when you start to get involved with CO2 systems, you need to learn those controllers. We are becoming control technicians, and this is the way it's going to be. So you need to start learning controls. You need to accept it, especially working on CO2s. It's all, you'll see all of them. It's all controls, and you need to start learning this stuff. Any questions so far? I don't see anything in the chat. Anyone want to jump out if they have any questions? No? Okay, if you do, you can just unmute yourself. So Copeland, CO2 semi-hermetics. So once again, an image I got up there is from a software called Copeland 8 software. So this is a European software. So if you're in Europe or any parts of the world besides North America, I highly recommend using that software. It's a great software. Here in Canada and the US, we use something called, they use something called product selection software, another good software to use, where it's going to talk about all the different parts. Similar, they're a similar software, but they're different because European will have different compressor models compared to North America. So just be aware of that. So same thing. So the semi-hermetic compressors, no different than Bitzer. That transcritical compressor, minimum superheat, 18F, 10K. Subcritical, that low temp is 36 Fahrenheit or 20K. You have to remember that. You have to be checking that, because when you start getting below that, you're starting to cause damage to the compressor. So the semi-hermetic say you want to keep the discharge below 250, 121C. We seen Bitzer said 284, I believe it was 140C. And you want to make sure you're keeping it below that, because when you start to get higher, it starts to cause more wear, more heat, and more damage. The protector on this one will trip off at 310. There's an internal probe there, so you can check that. Use your meter, get it out, and check the sensors. Bitzer has the same thing. They have internal PTC sensors inside the compressor, so when your temperature gets too high, it'll stop the compressor to protect it. So in there's lots of warnings. Once again, you have to be safe with any refrigerant you're working with. There's a lot of safety stuff that I didn't go through in the Bitzer one as well as in the Copeland one here. You need to read that stuff. I know I've been in the field. I definitely got complacent before, skip pages, but the safety, there's so many little tips and tricks there that you need to understand. And I highly recommend. This is an example. If your pressure gets below 722, shut down that compressor. So this is something you can program inside the controller. And the ones that I've worked at, that's what they program a lot of stuff. High pressure relief on the compressor. You can see it right over here, maybe. There's one right here. There's two of them on this one. The discharge one will be 1960. If these reliefs open, they need to be replaced. And it doesn't matter what compressor manufacturer, that's what they say. Oil level, quarter to 3/4. Bitzer says the same thing, quarter to 3/4. Safety relief valve should be replaced, like I mentioned. Safety valves copper coated, 34% silver solder with flux when you're brazing these in. Highly recommend practicing with that. There's a lot of components in with CO2 that are stainless steel, so you're doing dissimilar metal brazing. So just make sure that you understand how to do that. Take your time, learn how to do it properly, learn how to heat the joints up properly, heat the pipe up first, then the compressor joint. Turn on oil heater 12 hours before. And this is to prevent flooded starts, similar to what Bitzer says. Always isolate the compressor when pressure testing to prevent air, moisture, and oil. Same thing as the other compressor manufacturers. It's important. And you'll see over time when you're working, you're starting to read these guides, you're going to see a lot of similarities. There are going to be different uniqueness, like, you see the discharge, keep the discharge below 250 compared to a Bitzer, but you're going to see a lot of uniqueness. You want to keep moisture, you want to keep air out, you want to be running that oil heater before. Pressure test below 875, or sorry, 870, 60 bar. Always want to remove any component that doesn't meet that. For an example, if you're doing on the subcritical side, some of those components may only be up to 680 psi, or I think it's 45 bar. I'll have to double check that. But you want to make sure you pull those ones out if you're pressure testing higher than that. Do not run below 73 psi or 5 bar. That's below your triple point. Charge of 145, 10 bar. Here's one of the little differences. So this is Coleman grade 4. So you see in Bitzer was 4.5 and 4.5, which was less than 5 parts per million. They say less than 10 parts per million in their guide. Once again, doesn't matter what either one of them say, you need to make sure that refrigerant's going in dry. So if you have to use a filter to go before. Recommend charging through a filter dryer. Both manufacturers do recommend that. Keep that refrigerant dry. Here's another difference. So anything that I bolded was different than the Bitzer one. So minimum 10 starts per hour. Or Bitzer said 6 starts per hour. Copeland says minimum 10 starts per hour. And all this information that you want to get is from down below. There's AE 13696. And I'm going to show you how to get to these bulletins. So when you're working on them, you can find them fast. So 10 starts per hour. And then inverter, 25 hertz to 60 hertz. So if you're putting a VFD on there, the maximum is 60 hertz. That's a bit different. Then go down to 25 hertz. And once again, you need to look at the ranges. You need to get into the compressors. When you look at the European manual, it's going to say a little bit different. I believe it says 30 hertz to 70 hertz. So this is why you need to understand the actual compressor you're working on. So there's these little uniqueness. So you know that. And then they use MCRIT RL68. So that's the type of POE oil. Different viscosity. Moisture in oil needs to be less than 50 parts per million. So this is, once again, talking a lot about moisture in the systems, but I've seen a ton of it as as seeing and opening up hundreds and hundreds of compressors, doing trainings all over the place. There's moisture in too many systems out there. So make sure, especially with CO2, you get that moisture out. Here was another difference. I didn't bold this one, but Copeland recommends evacuating down to 225 microns, 0.3 mbar. 1 millibar equals 750 microns. So that's even lower than what Bitzer says. But this is the stuff that you need to be learning. So I know that you're servicing, you're in construction, you're working 12, 14-hour days. You got to find time to read these guides. When you're working on these equipment, you need to find these uniqueness, and you're going to get better at troubleshooting. You're going to get better at service. You're going to get better installing the equipment you're working on. Any questions on that one? The transcritical semi-hermetic for Copeland. Any questions so far? I don't see anything in the chat.
Yeah, I just had a quick question, Trevor.
Yeah.
I just wondering why you have to have the minimum 10 starts per hour.
Oh, that should be maximum.
Oh, okay, yeah, that makes
Yeah,
more sense then. Okay,
yeah, it shouldn't be minimum. I'm sorry, that should be maximum. So you don't want more than 10 starts per hour. So thank you for bringing that up. Dex. Yeah, so you don't want to go more than 10 starts per hour. So that's like running it for 3 minutes and off for 3 minutes, like every 6 minutes. Right. And
Okay,
that's
excellent. Thank you.
Yeah. Thank you for pointing that out. I'll probably have it on the next one too for the scrolls here. Okay. Once again, I didn't go through each one step by step like the first one, but minimum superheat 36 F. How you check this? You take your temperature probe, you put it on the suction right close to the suction service valve, and you take the pressure right from there. Take your pressure and temperature. Take your temperature over that converted pressure. You're going to get your compressor superheat, your total superheat, your system superheat. And this is what you need to make sure. You need to keep it below 36 or 20K. Maximum operating pressures on the ZO scrolls is 500 PSI. This is standstill pressure. Discharge 625. There's a mandatory safety relief of 500 PSI. This is UL rated for North America. They always need to be open to the system. So you have to have a valve on there where you close it and it always has that port open. So it's a two-way valve. One port's always open, and that's where that safety relief needs to be connected to, or it always needs to be open to the system either way on that suction line. Low pressure cutout they have in this one 80 psi or 5.5 bar. High pressure cutout 43.1 bar. I don't know why I didn't put the psi in there. Another thing, and I've seen this many times doing a field audit, going out with contractors, where certain compressors need to have check valves added on parallel rack system. What I mean by parallel rack system, multiple compressors, okay, tied in with a discharge and a suction line, a header. And on this one, on rack systems, a separate external check valve must be used. Inside the discharge, there is a spring-loaded check valve, but it's not for this purpose. And they're not to 100% stop everything. It's really to stop it from rotating backwards. This one here, you want to stop for any migration. You want to stop that, put that in the discharge line. If you're putting a digital on there, it's mandatory to have that external check valve in that discharge line. So make sure you're reading the proper manuals for these compressors. There's so much to learn. Copeland has over 25 different scrolls. They work differently. You need to invest the time to find out which ones you're working with. And really everything else is the same on there. Like you want to follow all the other procedures. You want to charge vapor first, and you want to put liquid in the system. You want to make sure you're pulling the proper vacuum. You want to use dry gas. You don't want to be getting dry ice in there. Okay. Questions? Some questions? Let's see if I can pull this up now. Does everybody see my screen here? You see the Google?
Yes.
Okay, thank you. So Bitzer software. Has anybody been to this before? Let's see a show of hands or yes in the chat. This is where you get all the information for Bitzer compressors. We're going to show you some of the CO2 stuff, semi-hermetics. You want to go here, change the refrigerant. We're talking about CO2, click on CO2, and then subcritical or transcritical, whatever one you're looking for. You can put in all the information. What I want to do is I just want to go to the documentation. Oh, you got to press play up here first. You press this little play button and it opens everything up. Go to the documentation. It's going to show you capacity, the slide, technical, the limits. Like here's the operation envelope where that is for these conditions here. If you want to change from imperial to SI, right here, you go down to here and you can change it. So if everyone sees that, because There's lots of people from all over the world are here on here, but this is the operation envelope. You always need to stay inside this operation envelope. Doesn't matter what compressor manufacturer you're dealing with, they'll have an operation envelope. Documentation right here. So what I was referring to today was out of this manual here. But you can see if you're working on Bitzer compressors, there's a ton of more manuals here. Look at this, oil heaters, reciprocating, all the stuff that you need to know, like bolt torques, it's going to be in here. Sometimes you're going to have to go out. If you go into them, for an example, if I go into this one here, it's going to say other manuals you need to look up. So if I just go down here, so this is a few different languages. Go to page 19. I know that's where the English starts. So I only know English, but if you go in here, right here, look, other documents, right here. That's what you want to look up. And to find these documents quickly, you can just go to Google, highlight it, and put it in Google, and it'll come up and find it. It is in the Bitzer software, but you got to go into when they have Transcritical, I think. Yeah, you go into Ecoline here, and then you can find the documentation for that one. So 104, I think this is the one I was talking about. So you need to use this stuff as a technician. You know, to be honest, I didn't use it because I didn't know about this stuff. Other ones. So Emerson, how to find the Copeland stuff. So if you're in North America, to find this stuff, you go to climate.emerson.com. You click on online product information. You go right here, publications and bulletins. You got to go here to US publications and then application engineering bulletins. And then under here, you do compressors. So quite a few steps, and then refrigeration. And then here are the guides that I talked about today. So we have application guide for transcritical CO2 and then scroll CO2 compressors. Very important to look at these guides, because a lot of times it doesn't come with the equipment, it doesn't come with the compressor. You need to find this stuff. For those of you that are in Europe or in other parts of the world, you need to go up here. You got to click on United States. Oh, sorry. You got to go back to the Emerson main website. You go up here and change your country to the UK. And this one's a little bit more work to UK, because there's differences inside the manuals. I've been through all of them. Probably not everyone, but a lot of the compressor ones, both in Europe and in Canada here. So CO2 compressors. I'm going a little fast, starting to run out of time. I like to talk a lot. Here's their new transcritical compressors. They don't have any technical documents on it right now. But we'll do the standard ZO. And then you go documents. So whatever compressor you want, manuals and guides. And here it is. So this is talking about their new ZOV with their new drive and stuff. And here's so much good content. And over time, after you read more and more of these, it's going to get easier, because you're going to see a lot of the similarities from the other manufacturers. Understanding the superheat, understanding the discharge temperature, understanding the amps, understanding that operation envelope of the CO2 compressors. And as you can see, there's 38 pages of great information on how to install it. The safety, big things, the safety, electrical, crankcase heater, mufflers, sound vibration. I've seen this a lot. I've seen many times where getting cracked lines on racks or on compressors because they weren't mounted properly. So great place for resources here. A lot of good information. Any questions on that so far? Oh, fantastic. Keeping with me. Okay, some educational resources. So r744.com, when you want to learn lots about CO2, that's where you want to go. I talked about the group already, Atmosphere group. They have a Slack group. If you want to get involved with that, shoot me an email, or message me on LinkedIn, and I'll get you the right connection to get connected with that, because it's a great place to learn, meet people within the natural refrigerant industry. I'm meeting so many different OEMs through there, getting connected, networking with people who are doing this. You want to become better at what you do, find someone who have already done it and know what they're doing, and get advice from them. Find a coach, find a mentor. Other resources for you: HVAC school, HVAC know-it-all, HVAC air school, and the tool shed. All these have so much great content, not directly for CO2 refrigeration, but definitely for learning refrigeration and HVAC. Can screws be used with transcritical CO2? Okay, I believe so. I believe you can use them. Vilter's been working on a project with their HLPD when I was working for Emerson, and they're in tests for many years. So I'm pretty sure screw compressors can work in with transcritical. You need to find out. You got to work with the manufacturer. Find out, reach out to that manufacturer. But I know they were working on the high pressure, low displacement compressor.